Let us see the static analyzer SACO working. We have here a class buffer implementing a buffer. It has a field f and two methods, produce and consume. In produce, we execute a loop while f times f is the field, and at each iteration we asynchronously invoke method doProduce and await for the termination of this method in this instruction, and thus the processor can be released at this point if the execution of doProduce has not terminated. In consume, we iterate m times, where m is a parameter of the method. At each iteration, we invoke method doConsume asynchronously, and we await for its termination. The important point of consume is that we increase the field value by 5. And this is important because these two methods can interleave their execution at the await instructions. Thus, method consume is modifying the counter of produce if this interleaving happens. Okay, so we analyze now the main method using SACO, and we select the resource analysis, and we are going to see the options configure the analysis, the configuration. So what we're going to do now is to have the options that we had before starting the project Envisage, in which we are going to measure the number of steps, and we are not going to enable the advanced options that have been developed in the project, like this, the two ones at the bottom. Okay. Let's see what happens now. We are not able to obtain an upper bound for the main method. We can see here a failed, and this is because the interleaving that I have explained before, and the fact that we are not able to bound the number of iterations that produce is going to perform. And one of the main achievements during this year in the project has been the development of a new analysis based. Oh, sorry, I wanted to configure the options. I'm gonna select the main method, and now we are going to configure the analysis, and we are going to select the new relay guarantee method that we have developed in the project. And this method allows us to have this kind of interleavings and still be able to find an upper bound on the cost. For main, this is the upper bound that we obtain. This is, as you can see, a formula that depends on the value for the local variable m, and also the maximum value that this field can take. Okay, so let's see now another aspect that we have developed in Envisage, and this is a small modification of the previous example buffer, in which we have the same produce method, but in consume we are not awaiting for the result for the termination of the execution of doConsume. So this means that we can have in the buffer many instances of doConsume, and we don't know if they have terminated or not. So now we have a main method in which we create two buffers, buffer O. In this one we first invoke produce, we await for the termination of produce, and then we asynchronously invoke consume. And at each iteration of consume, we might have many instances of doConsume in the queue of the object O. And then we have another buffer O2. In this buffer, initially we invoke consume, and we await for the termination of consume before invoking produce. But though we await for the termination of consume, we don't know if the invocations to doConsume terminate or not, because they are not awaited. Okay, so now we select the main method and we analyze with SACO resource analysis, but now we want to see the peak of the cost for each of the nodes in the distributed system. This means that we don't want to know the accumulated cost, but only what is the maximum number of steps that each of the distributed nodes might have to perform along the execution due to the tasks that are simultaneously in its queue. So this is captured in the peak cost analysis, and let's see what it gives us now. The first thing is that we can see to the right a graphical view of the objects that, or the nodes that are created in the distributed system. We always have this method executing the main, the initial object, 29, that is was already at 29, and then we have one object created at line 30 when executing from the object created at 29. This is why we have the two numbers here, and we have another distributed node created at line 35 when executing this object at 29. Fine, so if we select one of these objects, we can see its queue and we can see the peak cost that we have in this object. So this is the information that we get for the object created at line 30, and we can see in the configuration for its queue that we can have simultaneously in the queue method consume, undo consume, or method produce, undo produce, or the constructor init. So as we can see, because produce is awaited here and all instances of do produce are awaited here, we are sure that when consume starts to execute, there is nothing left of produce. And then the upper bound for this distributed node is the maximum between the upper bounds of these three configurations of the queue, which are given as formulas here. Okay, and then what we observe, if we look at the other buffer, O2, is that now we can have produce, do consume, and do produce, because do consume is not awaited. So it can escape from this scope here, and we can have it while we are executing the produce. It's only consume what is awaited, but not the tasks invoked from consume. And thus we obtain these three configurations, and each of these configurations has an upper bound which is obtained by adding the number of steps that each of these tasks has to perform. Okay, so finally let's see a new cost model that we have developed, which is corresponds to the traffic that we have between each pair of distributed nodes in the system. In this case, we are using a class master and a class slave, and a class for the main method main, in which we create a slave, we create a master and link to it the slave, and then we invoke on the master method work with some initial list and some initial integer value n. The work method is defined here in the master, and it performs a number of computations according to the second parameter that it receives. And at each of the iterations, we build a list L, which is increasing its size at each iteration, and we invoke on the slave method process and pass as parameter this list. We wait for its termination, and then we obtain the result that the slave is going to return. So in process, you can see that we return an integer 1 in all cases. So what we want to see now in this cost model is the amount of data transmitted between each pair of nodes of the distributed system. And for this, let's select the main method. We analyze with SACO, and in the configuration, now we don't want the peak, we want the total amount of data transmitted. We want to measure the traffic of data between the nodes. And as before, we get a graphical view of the nodes that are created in the distributed system. So we have the initial object executing the main, that it was already at line 31, and we have these two objects, the slave, which is 32, and the master, which is 33. And we can see the interactions or the amount of data between each pair of nodes. So for example, let's see how much data the master transmits to the slave. So we want to see the interactions between 33 and 32. It is this maximum amount of data that corresponds to sending at each of the iterations of this loop that performs at most n iterations, one message that has a constant cost denoted as CI, building a message, and in this invocation we are going to send a list, and this is the maximum size of the list, which is the one corresponding to the last iteration. So this is the amount of data in the worst case transmitted between the master and the slave, and we can see the data that is transmitted back from the slave to the master from 32 to 33, and in this case what we get is an integer value at each of the iterations of the while loop, and this is transmitted here in the get. So we perform n iterations, and at each of the n iterations we get a message C with constant size Ci and one integer that has size 1. And the same information can be also seen by just clicking at the nodes, and we see what is sent from 32 to 33, etc. Thank you very much for your attention.